Let's go through Liquid 131, Palindrome Partitioning. For this question, it gives us a string S, and let's partition the string S into return all of the palindrome partitions. For example, AAB, we can have A have separated as A, and B. So that's the first step partition. And the second one, A is also a palindrome, and also is B, right? So there are two different ways to do the partitions. So what we're thinking about is that we just to traverse those kind of partitions. So to traverse the partitions, we do the DFS, right? So DFS we from index 0, and the exit condition is the index equals the length. And when index equals to the length, then we add the result to our final result. And the some of the trimming condition is that if this kind of for some kind of partition, the index, right? When we try to add it to our path, this kind of substring, if it is not for example, AB is not an palindrome, then we should continue, should not add it to our result. So after this analysis, we just write code, right? So it should be kind of, this is kind of straightforward. Let's have n equals, actually we don't have n here. So what we let's have this integer result equals to new array list. And what we do is that we should have a DFS, this kind of string S with from index 0, right? And we are going to use this kind of intermediate list as a pass, right? And then result, then we just return result. So the DFS is also straightforward string S, right? So we have a current index and a list of string as pass, right? And a list string as result. So what we do is that if this kind of index, let's have its length out, int n equals s dot length. So what we do is if this kind of index equals n, then we have result add. Let's have a new deep copy, new string array list pass, right? And then return. Then what we do is that for int I equals index I smaller than n I plus plus, then we have string str equals s dot substring from I from index to I plus 1. Okay. Then we need to check whether this is palindrome or not, right? If this is the palindrome, is palindrome str, then we are able to have pass add this string, and also have options to remove. This is backtracking pass dot size -1. You know, we have do DFS, right? So as to I plus 1 pass result, and we write the Boolean is palindrome string as right. So we are going to this we use 2 pointers, char array equals s2 char array. So we have int left equals to 0, right equals array dot length -1, right? So what we do is that we just use the 2 pointers while left smaller than right. If array left doesn't equal to array right, we should return false, right? Then after this, we should have left move one step, right, move one step. And then in the end, if left and right mates, then return true. And Python code should be very similar. Let's we have result equals this, right? And we should do DFS as index 0, and we'll have pass result and the return result, this kind of list. Then we define DFS should have S as a string and index as an int, and we should have a pass as a list, right? And we should have result as a list. And what we do is that let's have n equals length s. If index equals n, right, we should have result append we should have pass, should do like this, and return, right? Then for I in range index and n, right? So what we do is that we have so we want to see whether this is a palindrome, right? So for Python it is pretty easy, right? So we should have this kind of substring class equals as index +1 to actually it is index to I +1, right? So we'll say if s equals substring equals substring this, right? Then we are going to do the DFS. So we should have pass append substring. Yeah, we should also have pass pop, and then DFS, right? So DFS si +1 to pass result. The time complexity, right? Time complexity, we for every index, right, we have options to partition or not partition. So that is a 2 to the power n. There is 2 to the power n, right? And for every partition, we should check whether it is n palindrome. So it is n multiplied by 2 power n, right?